But I am.
All right, sorry I was absent all last week. It was completely out of my control. But anyway, it's not like our house was a corona-infested hellscape. I took 2 naps a day and I ate cookies all day. It wasn't horrible. All right, so we're only going to do 1 day of personal progress check, go over stuff. So if you have questions after we do today's class, then tell me at the end of the period, and I'll make a video explaining those problems that you had questions about. And the tests will be tomorrow and Friday still. Okay? Everybody understand that? So we're only going to go over the personal progress checks for 1 day, and then I feel like we should move on. Okay? We didn't really lose a lot of time last week because we did the review pre-response questions. Hopefully you kept up with those and it helped you. But I feel like we should move on so we can finish new material as soon as possible and get on to the business of review. All right, so you had a question about it. Yeah.
Oh, never mind.
Okay. All right, so questions on the personal progress checks then?
Yes, this one.
Okay. Or anything else, like if you had questions on some of those pre-response questions and you didn't really understand my explanation, I'd be happy to do that too. Okay, anything you need help with. But since the test is tomorrow, maybe Unit 6 would be like the priority. And by the way, out of all those pre-response questions that I assigned, I think there was only one little section that was worth like 2 points that you weren't able to do at this point. So I mean, we're getting to the point where you could do a complete test and probably get 90% of it correct if you knew, like if you got it all the stuff that you should get correct. So that's good. Yeah.
Could you just write down like all the topics in Unit 6 that we're going to have a test on?
Sure. It's right here. I don't know if you guys can see this when you're in AP Classroom. The list of topics, like right here. I don't know what your page looks like, but for Unit 6, it's all about integration and accumulation of change. So the first one is just about exploring accumulation of change, and the whole idea there is if you take the definite integral of a rate function, you get the total amount of change. That's what that idea is about. Then it talked about approximating areas with Riemann sums, both left rectangular approximation, right rectangular approximation, midpoint approximation, and trapezoid approximation. Okay. Then talking about writing Riemann sums as summations using the capital sigma, and then changing summations into definite integrals and vice versa. FTC part 1 in accumulation functions, that's like if you want to find the value of a function, like f of b, you just need to find the value of a function at a particular point and then take the integral from a to b of f prime of x. So this is FTC part 1, just written a different way, finding values of functions. Interpreting the behavior of accumulation functions involving area. I think that involved things like if they give you an f prime graph, determining when f is increasing, decreasing, concave up, concave down, okay? Using the area of a curve. Properties of definite integrals, that's just those 5 basic properties, like the integral from a to a of f of x is 0. The integral from b to a is the negative of the integral from a to b, and so on, right? There's those 5 basic properties. FTC and definite integrals, I think that's just FTC part 1 again, or it might be part 2. Yeah, I think that might be part 2 actually, which is the definite, or the derivative of a definite integral is just the integrand itself. Finding antiderivatives and indefinite integrals, basic rules. Okay, so that we did that actually probably in Unit 5, but that's okay. Integration using substitution, that's U substitution. integrating using long division and completing the square. We actually did this assignment directly, just because they didn't have a good delta math assignment on it. And then just selecting techniques for anti-differentiation, looking at an integral and determining what method you should use. And that was it. That's what that unit was about. So can you guys see this on your page? Like,
Yeah.
different?
Yeah.
Okay, so that's a good way to kind of review, like, if you understand everything, you just look through the topics and that's what we think about it.
Now, I know that all of our tests are always like review can be on, but this one's just primarily on like unit 6, right? It's not like any cumulative overall, like the last one.
No, yeah, it's not totally cumulative, but there's definitely stuff from other
Yeah,
units. Yeah, that, like, in the process. Okay, yeah, go ahead.
I just forgot, is the calculator part Friday or Thursday?
The calculator part will be Friday. Tomorrow, no calculator. Okay? And if you're not going to be in class for any reason, take the test on Delta Math between 9:20 and 10:20. That's when it'll be open and you can take it. It's definitely better for you to be here, though, to take the test, I think. It's a better situation. Yeah.
Okay, I have a question now.
Wait, just one second. Any other general questions before we go into actual problems? Okay, go ahead.
So multiple choice part B,
Okay.
question number 2.
Number 2.
I was just looking at that. Yeah, I don't know.
Okay, so they give you a table of data, and it says, select the values of the twice differentiable functions from the table. What's the value of this? Okay, so this is a tough one because I think it involves a trig identity. And the trig identity is, boy, I wish I knew. Cosine squared A is, I actually have to look at a page of trig identities, and I'm looking, this is just the formula sheet. The formula sheet from, reference sheet from the old Algebra 2 Regents exam. This is where I get my stuff from. This is a tough one. All right, so here's the deal. There's a trig identity that says cosine 2a equals 2 cosine squared a minus 1. So if you solve for cosine squared a, you get 2 cosine squared a equals cosine 2a plus 1. And so cosine squared a rather, is cosine 2a plus 1 divided by 2. Okay, so that's an identity. I don't expect you to know that. Apparently they did for this question, but I'd be really surprised if they expected you to know that for the actual AP test. But anyway, now that I've shown you this, hopefully it's a little more clear. What you could do is you can use U substitution here. You can say U is equal to 2g of x plus 1. So then du is 2g prime x dx. Everybody cool with that so far? Now, if you make that substitution, you get the integral of g prime of x times cosine squared of u times 2g prime. Oops, I forgot to solve for dx. Dx is equal to du over 2g prime of x. So this is going to be du over 2g prime of x. So then these just cancel, right? So now you have 1/2 of the integral of cosine squared u. So now I can make this trig substitution. This is really 1/2 of the integral of cosine 2u plus 1 over 2. Yes. Which, the 2 here, is a 1/2 constant, and this is a 1/2 constant, so you get 1/4, right? The integral of cosine 2u is sine 2u over 2. And the integral of 1 is u. Right? So now I would replace back into x's and then evaluate from 0 to 3. So let me do that. This is going to be 1/4 of sine u was equal to 2g of x plus 1. This is a really hard problem. So this is 2 times 2g of x plus 1 divided by 2 plus u, which is 2g of x plus 1. And we want to evaluate that from 0 to 3. So we have 1/4 sine of 2 times 2g of 3, which they tell us g of 3 is -2, plus 1, divided by 2, plus, same thing, 2 times -2 plus 1, minus 1/4 sine of 2 times 2 times g of 0, 5, plus 1 divided by 2, plus 2 times 5 plus 1. And then just do that on your calculator. This is a calculator question, but that's the first time that your calculator is helpful. Make sure your calculator is in radians, because this is like 2 times -3, so it's sine of -6 radians, plus -6, and so on. Good. Does that make sense? That was a hard problem. It was hard for 2 reasons. The first is that trig identity that nobody knows. And then the second, the only trig identity that I expect you to know is if you take the sine of a double angle, it's 2 times sine A cosine A. Because that's kind of easy to remember, and it comes up the most frequently out of trig identities, okay? So that's the first hard part about this problem. And the second hard part about it is it was a U substitution that was a little weird, because it wasn't an actual thing. It was really kind of abstract. All right, what else? Yeah.
Can we do number 10 on part A?
Wait, before he does that, can you just click it so you can see what it is?
Yeah, sure. What do I do? Click this?
Just,
No,
just
this.
click the on random answer. Or do that.
Click it.
Oh, see, yeah. Yeah. Let's see if they did what I did.
Yeah.
Oh, you know what? It's a calculator question. They didn't actually do this trig identity. Okay, so they don't expect you to use the trig identity because you have a calculator. So we could have, at this point, just done this integration without knowing how to do it. You know what I mean? By using your calculator. But remember, when you enter something like that into your calculator as an integrand, you got to enter it as cosine u squared. Okay, so just be careful about that. Sorry, I forgot this was a calculator question until the end. Anyway, all right. Any other questions on that problem? All right, that took a long time. So you said part 2, number 10?
Yeah, I said part A, number 10.
Part A. Okay. Are we on part A? We're on part B. How do I go back? Part A.
But we can do this one too. I think I got this one wrong.
This one too? Just FOIL it out. I think that's the easiest way to do it. So if you FOIL this out, you get 4x to the 6th plus 4x cubed plus 1. So it's A. Missing something? Right? If you FOIL this out, it FOILs out to give you that.
No, I think you're good.
I think that's it. A? Yeah, that's it. Just FOIL it out. Okay, so let's see now. I'm gonna figure out how to do this. I can't even answer my phone sometimes, I swear to God. Don't laugh. Part A?
Yeah, number 10.
Okay. Okay, so this is an FTC Part 2 question. They want you to find the derivative of a definite integral. So remember, all you need to do is substitute this expression in for t, and then do the chain rule. So this is going to be square root of 2 plus x, is that a cube? Yeah, it's a cube. X cubed squared times 3x squared. That's the answer. So it's this one. It's D. Remember, if you have the derivative of the integral from a to u, a is any number, u is any function of x, and this is like f of t dt. It's just going to be f of u times u prime. That's it. If the u happens to be on the bottom, and remember it's just negative, and if there's a u here and a v there, like two functions of x, you got to subtract them. That's it. Those are the variations of FTC Part 2.
I was just gonna ask.
Yeah. So it would be like you plug this in and do the chain rule, and then you plug this in and do the chain rule, you subtract it. Anything else about that one?
Can we go over to the ones part 2?
Sure. Okay, so they're giving you a graph of f. Be careful, when they give you graphs, sometimes it's f, but more often it's like a derivative. So just be really careful and make sure you know what they're giving you. This is the graph of f. And they're saying g of x is this definite integral. So the first thing I would do in this problem is I would say g prime is f of x. So like I said, oftentimes the graph they're giving you is actually a derivative. This is g prime. So that's the first thing that I would do in this problem, is do FTC Part 2 and make this connection because it's really important to the problem. I haven't even read the problem, but I know it's important, right? It says, on which of the following intervals is g decreasing and concave up? This is g prime. So g is decreasing whenever g prime is negative. So that's on this interval, right? This is the interval where g is decreasing. So then if you want to know when g is concave up, you want to know when g double prime is positive, right? Well, g double prime is the derivative of this graph. That corresponds to from here to here. That's the part at which g is concave up. So the interval on which both those things are true is from 0 to 2. I'm sorry, from 1 to 2, rather. 1 to 2. So this corresponds to choice D.
Yeah, I read it as the graph of G. So.
Okay. Yeah, this is essential, like looking at what the graph they're giving you is. And then this is a really common type of question. Making that connection that G prime is actually the graph they're giving you is like fundamental. If you can't get that connection, there's no chance you're going to get it right. Okay, so you got to be careful. Are we okay if I erase? What else? Anything at all? Yeah.
Yeah, on part B, I know.
Part B.
Yeah, I'm sure.
Free response or multiple choice?
Multiple choice.
Okay.
question number 9.
Okay. What do you guys think? Long division.
Yeah.
My first thought is it possible to do this using U substitution because it's a non-calculator question? And I'm looking at it, it's not possible to do U substitution because in order to do U substitution, I would tend to think the denominator would have to be U in this situation, which it can't be because the top is a cubic and the bottom is a quadratic. And then even if I tried to think somehow maybe the top could be U, even though that's weird because its derivative is a quadratic, which is good, but this is not a constant multiple of its derivative of a quadratic. It's like the reciprocal of a quadratic, so it's no good in lots of ways. So this has to be long division. So let's do the long division. You have 2x cubed minus x squared plus 2x plus 2. And remember, when you do long division, you have to have a placeholder for the x term, or else things don't line up correctly. So I have x squared plus 0x plus 1. Right? And then it's going to be x, and then x, right, 2x. 2x, and then 2x cubed plus 0x squared plus 2x. Subtract, everything cancels, and you just get 0 plus 2. So this is really 2x plus 2 over x squared plus 1. Right?
Well, not everything cancels, right? See that negative x squared.
You're right. Yes. Go away. So this is negative x squared plus 0x plus 2. So now I have minus 1. So this is negative x squared plus 0x minus 1. Subtract, which means this sign has to change and you get 3. So the remainder is 3. So this is plus 3 over x squared plus 1. So if you take that integral, you get this is strange.
Yeah, I didn't know what to do with that.
Yes.
So what do you guys
For
think?
the answer, it's an inverse straight function.
Right. This is inverse tangent directly, right? This is 1 over x squared plus 1, which is inverse tangent. So this is going to be 2x squared over 2
should just know that.
minus x plus 3 inverse tangent of x. This is kind of a tough problem for just because you have to recognize that. 0 to 1. You plug 1 in, you get 1 minus 1 plus 3 inverse tangent 1. And if you plug 0 in, you get 0 minus 0 plus 3 inverse tangent 0. So what's the inverse tangent of 1? You should know this really quickly. The angle whose tangent is 1 is there's no such thing as degrees. Pi over 4. So this is 3 pi over 4. What's the angle whose tangent is 0? 0.
Good things like that, I just don't have stuff like that.
You gotta know trig values for sure. This is a pretty tough question. So this is another one. Remember, this is a non-calculator question, so you have 2 minutes to do it. So this is one that would probably take you longer than 2 minutes, but you know you'll make up for it in other problems where you can do them. Okay. Everybody good if I erase? All right, what else? Yes?
Question 4.
4?
Yeah, that was good. Yeah, people don't play.
Okay, again, I'm taking notice. This is the graph of G. piecewise linear function. And again, they're giving us this. So I know that f prime, I'm making the connection, f prime of x is really g of x squared times 2x. It's that, right? So if you're trying to find f prime of 3, it's going to be g of 9 times 2 times 3. So g of 9, this is graph of g. G of 9, this is piecewise linear. So g of 9 would have to be 4. This is 4 times 6. The answer is 24. FTC part 2. Super easy to use. You have to make sure you recognize when you're supposed to use it, though. What else? Yeah?
Number 6.
Same set?
Yeah.
What type of problem is this?
I don't know if I got it right.
You should know. This is easy. This was easy. U substitution. This is straight U substitution. U is the stuff in parentheses. U is 6e to the x plus 3. du is 6e to the x dx. dx is du over 6e to the x. So I have the integral of e to the x sine u times du over 6e to the x. Those just cancel. I get 1/6 times negative cosine u. So the answer is negative 1/6 cosine of 6e to the x plus 3. Plus c. So it's choice C. Now, what if you get to a problem like this and you're not sure how to do it? Is there a way you can still get the right answer? Yeah, you could just start taking derivatives and see which one equals that. Okay, you can see that the derivative of this would definitely be that, right? Quickly, like this is a negative 1/6 constant. The derivative of cosine is negative sine, which you cancel with that negative. And then when you do the chain rule, the 6e to the x, that 1/6 will cancel with the 6. You can see it in your head that that's going to work out. This, no way, because this is going to require a product rule, and this is not, this integram here is not a sum. Same thing, like, not same thing, but here if you did the chain rule, you'd have a 36 factor. Here if you did the chain rule, you're not going to have a negative that cancels with the negative. You know what I mean? So you can check this pretty easily without doing this. It might even be quicker to do it that way. I don't think I would do it that way generally, but just because sometimes it's not quicker to do 4 derivatives than it is to do 1 U substitution problem. But keep it in mind, like keep that in your toolbox that you can do that if you have to. Okay? What else? Yeah.
8 on this one.
8. Okay. Number 8. What type of problem is this? Inverse sine, and also what else? Completing the square, right? Because if you think about it, when we do inverse trig or whatever, I mean, I can tell it's going to be inverse trig because that's 3 of the 4 choices. That's a good hint also. But anyway, I know it's going to be completing the square because normally inverse sine has to be the inverse or the integral of 1 over square root of 1 minus u squared. Like, it has to look like that in order to do this, and this doesn't look like that, right? Let's try it. It's a little weird because whenever there's a negative with the leading term, I get confused about U substitution. But let's try it. All right, so I have the integral of 10 over, leave a little bit of space here. This is, I'm trying to even think how to like write this. I'm going to factor out a negative because I get confused by that negative. So that's what I'm gonna do. I'm gonna factor out a negative, and I have 4x squared minus 8x, and then I'm gonna leave some space. Actually, I'm gonna factor out a negative 4. Even better. I'm gonna factor out negative 4, and I have x squared minus 2x. Now the square is really easy to complete. I'm going to add negative 1 squared here, and I have to subtract negative 1 also. Am I doing this right? I'm adding 1, right? But as a net result, what am I actually doing? I'm actually subtracting 4. So I have to add 4 here. Write it that way. Everybody okay with what I've done so far? So now I have the integral of 10 over the square root of negative 4 times x plus 1 squared, or x minus 1 rather, plus 4. Now I'm going to switch these terms again just to get you back to the way it's supposed to look. So this is 4 minus 4 times x minus 1 squared. Now the 4 is the problem here, right? So I'm going to multiply the top and bottom by 1/16. Yeah. By 1/2. 1/2. That's okay, right? I'm allowed to do that. So on the top, I have 10 halves. And now I have 1 over, if I distribute that in here, I get square root of 1 minus x minus 1 squared. So this is 5 times inverse sine of x minus 1. This is one of those ones where if you did u substitution, you can do the shortcut because the derivative of the u that I'm going to pick, which is right there, has a derivative of 1. So I just divide by 1. Like I could think of this as like dividing by 1, plus, and that's it. So 5 sine inverse, it has to be c then. Oh, a hard one too. You guys have good questions. This one was completing the square and like a weird inverse trig problem. What else? Don't be shy. Anything at all. How about other stuff, like from those free response questions or anything you don't understand? Did doing those free response questions give you confidence, or was it like, oh God, I'm screwed? Depending on the day. So raise your hand if you feel like, on average, you got 6 or more points out of 9 on the free response questions. Okay, that's good. 6 out of 9 points is a 5, solid 5. So if you're constantly getting 7, 8, maybe 9 points on free response questions, that's outstanding. That's really good. Next question. Raise your hand if you were able to complete the free response questions in about 15 minutes each. That's kind of the hard part for people at this stage. After we do more problems, you'll get better at doing it quickly. But remember, you're going to have about 15 minutes each. So if that's your issue, then you just got to work on like just getting stuff down so that you recognize it right away, knowing what type of problem it is, and moving on to the actual work. I mean, I know stuff pretty well, and it takes me like 10 minutes to do a problem, which is like, for you to do it in 15 minutes, when I write a test, I try and write a test so that I can do it in half the amount of time it's going to take you. So if it takes me 10 minutes to do a problem, for you to do it in 15 is going to be a tough thing to do. You know what I mean? So that's why there's so hard to get a good grade in terms of, if you get in the 60s, you have a 5. That's pretty terrible if you think about it. But that's why. It's time mostly. It's not that people don't know what they're doing. It's that they don't know it well enough to do it quickly. So that's the goal, is to learn it well enough so that you can do it quickly. Any other questions? All right. Miss you guys. I had all my work done by 9:30 every morning.